So question 17 is basically an iteration question to finding the roots of this cubic. And we're told that the root is suspected to be between x is equal to 1 and x is equal to 2. And we've got to prove that to be true and then form an iteration equation and then work out the actual position of the root. So what's happening here is that, and I'm not pretending this to be in any way representative of what the curve actually does, we've got this function, which is a part of a cubic, and we're told that there is a suspected root between x is equal to 1 and x is equal to 2. And the thing is, if I put that value of x is equal to 1 into the function, I will get a negative answer. And if I put this value of x is equal to 2 into the function, I will get a positive result. Maybe, or it could be the other way around depending on the slope. But at least there will be a change of sign as the function goes through 0. So all we've got to do is try x equals to 1 into our equation. What do we get? X is equal to 2, and compare the results. So sub x is equal to 1. If we do that, we get an answer of negative 3. And if I sub x is equal to 2, I get an answer of 6. So actually we are at least round the right way here. We are going from a negative value, crossing the axis and ending up at a positive value of y when x has gone from 1 to 2. And there I've written down, as there's a change of sign, there is a root between x is equal to 1 and x is equal to 2. And that completes part A. Part B, we've been asked to rearrange the cubic into this form, where you've got a value of x on both sides of the equation. Now, to find out which x they've picked, it's wise just to have a look at this and backpedal slightly. If I cross multiply this, I would get x cubed plus 2x. So what they've done is they've taken an x out of the first two terms and then made that the subject. Let me show you. So taking that x out, this becomes x squared plus 2. And I might as well put the 6 on the opposite side. This becomes positive 6. Now you can see what's happening. So that x must be equal to 6 divided by x squared plus 2. So there's the proof for part B. Now part C, and this is where the fun starts. So we've got to use this now iterative equation. The new value of x is on the left-hand side, and the old value is plugged into the formula on the right. We're going to start with the first value, x0 as 1.45, and we need to go around the loop twice to find an estimate of the solution to our original cubic here. Okay, so our iterative formula is this. So x0 is equal to 1.45. And I'm sure you know the routine. What you do is you go 1.45 equals ANS. So in the calculator, you set up that 6 divided by answer squared plus 2 is the calculation you want to make. And if you push equals, you will get the first improvement, and this will be x1. And if you do that correctly, you'll get an answer of 1.4625. If you do it again, as the question is asking, just by pushing equals once more, you'll get the answer of x is equal to 1.4496, and this is to 4 dp. If you don't quite understand the routine and how to use that calculator in that way, do practice it or look back at previous tutorials about finding the solutions to iterative equations. And that's the answer to question 17.